Today we will discuss from the refrigeration of air condition psychrometric chart. What is the psychrometric chart? It is a graphical representation of the various thermodynamic properties of moist air, and the psychrometric chart is very useful for finding out the properties of air, and it is very useful because it have not any calculation to find the properties of air. Normally the chart is seen like this, and it is drawn between in the atmospheric pressure of 760, that means 760 millimeter of Hg. Hg, that means pardon, that means Hg, or 1 atm, that means 1 atmospheric pressure, or 1.01325 bar. This is the standard value of atmospheric pressure. The psychrometric chart, dry bulb temperature is taken as abscissa and specific humidity as ordinate. In which ordinate? This is the dry bulb temperature. This line is dry bulb temperature, and in the y-axis this line is specific humidity. This graph, the pink color line, this is dry bulb temperature and this is specific humidity. Dry bulb temperature calculated in degree centigrade and specific humidity calculate of kg of water per kg of dry air. Okay. What is dry bulb temperature? These lines are vertical and parallel to the ordinate and uniformly spaced. This is dry bulb temperature. What is specific humidity or moisture content line? This is line is specific humidity line. These lines are horizontal, that means the graph is like this type, and parallel to the abscissa and uniformly spaced. This line is called the relative humidity lines, which is a curved line. This blue color line is called relative humidity line, and this line, main line of this curve parallel to the relative humidity line, is saturation curve. This saturation curve is, and this inclined line is called specific volume in meter cube per kg of air. These yellow lines, you can see these yellow lines. This yellow lines is wet bulb temperature. You can see this yellow lines is wet bulb temperature, and these black lines, which is parallel to the dry bulb temperature and vertically to specific humidity lines, this black lines is humidity ratio lines. The saturation line is, these lines are curved lines and follow the saturation curve, and this is saturation curve is represent 100% of relative humidity. If the saturation line is 100% of relative humidity, then the another lines is 90% below the saturation line and 100%, 90%, this is 80%, this is 70%, anything you can see. This graph, this scale is measured to enthalpy in kilojoule per kg, and another scale, you can see another scale, there is, this scale is my vapor pressure scale in millimeter of Hg. This is my psychrometric charts. Now we discuss about the psychrometric processes. What is psychrometric process? What is psychrometric? The various psychrometric processes involved in air conditioning to vary the psychrometric properties of air according to the requirements. First, we have discussed about the sensible heating. What is sensible heating? The sensible heating of air without any change in its specific humidity is known as sensible heating. Let us see. If it is a system there is a line which can pass the steam across units, and the air is passes through the pipelines. This is air in and there air out. Let air at when the air is in the system, the temperature is TD1 and passes over a heating coil. When this steam is passes, this is heating coil. This is my heating coil. There, when the passes over the air, the temperature will TD3 and TD2. The temperature of air leaving the heating coil, the TD2 will be less than TD3 because the temperature steam is across, the steam is inside and out in that side. So the temperature will be greater than the TD3 and TD2. Now the chart, what is my psychrometric chart? This line is specific humidity. This is dry bulb temperature. Now this is my saturation line. There is enthalpy. Now what happened? In the sensible heat processing, shown that horizontal line 1 to 2, this is 1 to 2, this is my point 1, this is point 2, and this is point 3. There is the relative humidity curve. 1 to 2 extending from left side to right side, and the point 3, this is point 3, represent the surface temperature of the heating coil. It may be noted that during the sensible heating specific humidity remaining constant. That means there is constant value of specific humidity. The W1 is equal to W2, and the dry bulb temperature increases from TD1, this is TD1, increases to TD2, and relative humidity decreases from phi1 to phi1, this is 1, phi1 to phi2. Now this is phi1 and this is my phi2. Now the bypass factor, that means BPF for the heating coil, that means BPF so on is equal to TD3 minus TD2 by TD3 minus TD1. This is point my TD3, last point. And the efficiency we generated eta H for enthalpy is 1 minus BPF is equal to TD2 minus TD1 by TD3 minus TD1. This is my sensible heating. Now next is number 2 is sensible cooling. Sensible cooling is the opposite of sensible heating process. There the cooling coil is occur. There is heating coil, there is cooling coil, and the air is also passes through the over the coil. Their temperature is TD1 and their out temperature is TD2 and TD3. TD3 is greater than because the cooling coil is passes through in the lower side to top side, upper side. Lower side cooling materials its temperature is very low, upper side is high, because that passes through the when the passes through in the system its temperature will be absorbed. Now there the psychrometric chart is shown like this is phi 2 and this is phi 1. This is W1 is equal to W2. This is specific humidity is constant. This is process 1 to 2. The process is occur from right side to left side, and this is process 3. There is TD3 This point is TD2 and this is TD1. Thus this temperature is greater than the TD1. TD3 is greater than the TD1. Now there the bypass factors, that is BPF is equal to TD2 minus TD3 by TD1 minus TD3, and the efficiency is called 1 minus BPF is equal to TD1 minus TD2 by TD1 minus TD3. Okay. Next is humidification and dehumidification. Humidification and dehumidification. What is humidification? The addition of moist to the air without change in its dry bulb temperature is known as humidification. Similarly, the removal of moist from the air without change in its dry bulb temperature is known as dehumidification. Okay, we can see in psychrometric chart what is humidification. Humidification line we like that this is process 2 and this is point 1. The line will, this is humidification line. This line is called humidification line. This is my phi 1 and this is phi 2. This is my relative humidity curve. This is saturation line. There sensible specific humidity is not constant. But the dry bulb temperature is constant in humidification. And dehumidification is the opposite of humidification. That means the process is from upper side to lower side. This is in lower side to upside and this is upside to low side. There also the dry bulb temperature is constant, but the specific humidity is not constant. Okay. Next is cooling and dehumidification. In this process, the generally we used in summer in air condition. What happens in summer? To cool the dehumidity of air, the air is passed over a cooling coil or through a cold water spray. In this process, the dry bulb temperature as well as the specific humidity of air is decreased, and the final relative humidity of the air is generally higher than that of entering the air. And the dehumidification of air is only possible when the effective surface temperature of cooling coil is less than that the dew point temperature of entering the coil. We have seen the psychrometric chart what happened in the cooling or dehumidification. This line is specific humidity. This is dry bulb temperature. This is my saturation line. In that, the process is from this is point 1, this is point 2, this is point 3, this is point 4. There, this is humidity W2, this is W1, this is TD1, this is TD2, and this is TD4. There is enthalpy. There we can see the H1, H2 is this is H1, this is HA or H3, HA, and this is H2. This difference is called SH, and this is LH. This SH is denote sensible heat and LH is denote latent heat. Now in the process, dehumidification process, we can see Q is equal to H1 minus H2 is equal to H1 minus HA plus HA minus H2 is equal to LH plus SH is equal to LH plus SH. Now what is LH? LH is equal to H1 minus HA is equal to latent heat removed due to condensation of vapor of the reduced moisture, and SH is equal to HA minus H2 is equal to sensible heat. This is removed, sensible heat removed. Now my sensible heat factor, that means sensible heat factors, that means SHF is equal to sensible heat by total heat. That means SH by LH plus SH is equal to HA minus H2 by H1 minus H2. Okay. Next is number 5, heating and dehumidification. Heating and dehumidification. What is heating and dehumidification? In this process is generally used in winter season of air conditioning to warm the humidity or humidify the air, because the winter season the air is already cold. To increase the air temperature, we use the heating and humidification process. It is a reverse process of cooling and dehumidification. The process of heating and humidification is like in the psychrometric chart we can see this is dry bulb temperature, and this is specific humidity. In this process, the line 1 to 2 this is heating or humidification line. In the line, the air enters at the air condition in point 1 and leaves from the air condition is point 2. In this process, the dry bulb temperature turns as well as specific humidity of air increase, and the final relative humidity of air can lower or higher than that of entering the air. This is W1 and this is W2. This is point A. Now we can see the enthalpy. This is my enthalpy. We can see the enthalpy. Is the enthalpy line. This is LH from there to there. This is LH and this is SH. This is point H1, this is point HA, and this is H2. Now the sensible heat factor SHF is equal to SH by SH plus LH is equal to HA minus H1 by H2 minus H1. Okay. Now the last process is heating and dehumidification. Heating and dehumidification, or this process is called adiabatic chemical dehumidification. This is the most important term. We can see the heating and dehumidification process is also called adiabatic chemical dehumidification. Okay. In this process, mainly used in industrial air conditioning and can be used from some comfort air conditioning installation requiring with either a low relative humidity or low dew point temperature in the room. In this process, the air is passes over the chemicals which can a affinity for moisture, and as the air comes in contact with these chemicals, the moisture get condensed out of the air and gives up its latent heat. Due to the condensation, the specific humidity decreases and the heat of condensation supplies the sensible heat for heating the air and thus increase in its dry bulb temperature. We can see the process in the psychrometric chart. In this process, which is the reverse adiabatic saturation process, the line 1 to 2 from line 1 to 2 on the psychrometric chart. The path followed during the process is along the constant wet bulb temperature line or constant enthalpy line. This is air condition in air and this is out. There another point is occurred, that means point 3. There is 3 point of specific humidity, that means W1, W3 and W2. And the dry bulb temperature is also 3 point, that means DT2, TD3 and TD1. And the effectiveness or efficiency of the dehumidification is given like that. H1 is equal to actual increase in dBT, that means dry bulb temperature dBT, by ideal increase in dBT, that means dry bulb temperature. That means actual increase, that means from point TD3 to TD1, this is my actual increase, and ideal increase is TD2 to TD1, that means TD3 by T minus TD1 by TD2 minus TD1. Okay, these are the process of psychrometric chart for the air conditioner. Okay, thank you.